Hi everyone, how are you all? Welcome back to Wang RB channel. Thank you for watching. Please don't forget to like, comment, share, and subscribe to Wang RB channel. And if you would like notifications and updates on all of my videos, please click the bell button and then click the all notifications bell. So are you ready for another math fun field day? So let's go! Today we'll have scientific notation. So let's learn together. First, let's familiarize ourselves with the following terms in connection with our lesson, which is scientific notation. Notation is a way to express numbers or concepts in writing. Scientific notation, on the other hand, is adjective that means relating to science or something that is systematic or methodical. Standard means normal, typical, or established. And scientific notation is a way to easily write very large number or very small numbers. Now, here are the questions. Let's think about this. When and why do we use scientific notation? And how do you know if the exponent and the power of 10 is positive or negative? So these questions hopefully will be answered as we go along on this lesson. Again, so why do we use scientific notation? This is to write very large number or very small numbers. And remember, there are some parts of a scientific notation. The first part is a number greater than or equal to 1 but less than 10. And we have this multiplication symbol and the number 10 raised to a power and then the exponent. So I hope you will remember those parts as we go along. When and where do we use scientific notation? Is it really important? Do we use it in real life or in this world? Well, yes it is. We can use it in writing the following examples. Mass of an electron, the approximate number of cells in the human body, which is 1 times 10 to the 14th power. Distance between Earth and the Moon, which is 2.5 times 10 to the 5th miles. The distance between Earth and the Sun, which is 9.3 times 10 to the 7th power miles. And approximate speed of light is 1.08 times 10 to the 9th power kilometer per hour. There's a lot more. So, well, scientific notation is really important. Scientific notation, also called standard form in Britain, is a special way of writing numbers. So whether you write a small number, a big number, or a regular number, it could be written in scientific notation. Example is 700. This could be written as 7 times 10 to the second power. How about a big number like 4,900,000,000? This could be written as 4.9 times 10 to the 9th power. So, how will we write a number to scientific notation? We will be learning more how to convert them as we go along. So how do we convert big numbers to scientific notation? Here are the steps. First, we have to move the decimal point to make the number greater than or equal to 1 and less than 10. Second, count how many places the decimal point moved. The third, write the number without the zeros. And then last, we have to multiply it by a power of 10. The exponent will be the number of places the decimal point moved. So here it is. We have 819 million. So since this is a whole number, the decimal point is at the end of the number. So it's always after the last digit of a number, which is here on our example, 0 is the last digit. So we have the decimal point after the last 0. Counting the number of places where we will be moving the decimal point, we have 1, 2, 3, 4, 5, 6, 7, 8. So we end up with 8, okay, at the left of the decimal point because we said that it should be equal to 1 or greater than 1 but less than 10. So that is why we have ended up there. So we've got 8. And then 1 and 9 are also non-zero digits, so we have to include them. And we have to drop all the zeros. So this is how it looks like. 8.19 times 10 to the 8th power. So don't forget that we have to retain all the non-zero digits, drop all the zeros, and then multiply it with a power of 10. And then the exponent will be based on how many places we have moved the decimal point. So the answer for this, the 819 million in scientific notation could be written as 8.19 times 10 to the 8th power. How about converting small numbers to scientific notation? Well, the process or the steps are the same. However, to make this number greater than or equal to 1 and less than 10, the decimal point must move to the right. So it means that from left, you have to move to the right. So taking a look at our example, which is 0.000000819, we can start from the decimal point, which is there already. So from left to right, we have 1, 2, 3, 4, 5, 6, 7. So we stop at 8, or the decimal point is after 8, which is greater than 1, but it is less than 10. And then we can now write 8 and then point. We have to include 1 and 9, which are non-zero digits. Then we have to multiply it by a power of 10, and then the exponent is 7. However, the exponent now is negative because we have moved from left to right. To understand more about scientific notation, let's take these examples. 5,200. So, moving from right to left, we could have 1, 2, 3. Okay, at the end of the number, which is after the 0, we have 1, 2, 3 places. So that is why we have the decimal point after 5. And then we retain the 2, which is a non-zero digit. And then we multiply it with the power of 10 times 10. And then the exponent is 3, a positive exponent, because we have moved from right to left. Number 2 example. We have 0.0000000078. Now, since the decimal point is at the left, we have to move from left to right. So if we count the number of places that we will be moving, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright? So we have 7, which is greater than 1 but less than 10. And then we have 8, which is a non-zero digit. That's why it is going to be with 7. So 7.8 times 10, the power of 10. And then we have 9 as your exponent. However, this is negative because it moved from left to right. It is a small number. That is why it is a negative exponent. So the final answer, 7.8 times 10 to the negative 9 power. So always remember that we have 7.8 as the digit term and 10 to the negative 9 as the exponential term. So we usually have these parts. Here are some examples or more examples. So scientific notation, there should be a number between 1 and 10. Okay, or we say equal to 1 but less than 10. Or it could be greater than 1 but less than 10. And then we have to multiply it with an integer power of 10. So example, we have 5.2 times 10 to the third, 8 times 9 to the 9th power. Or we could have a negative exponent, which is 4.391 times 10 to the negative 2. Let's try these examples. Determine whether its number is written in scientific notation or not. I'm giving you 20 seconds to try, and then let's come back together to check your work. Ready? Go! Alright, let's check your work. The first one, 10.6 times 10 to the 14th. Well, the answer for this is no. Why? Because the first term should be less than 10. It could be equal or greater than 1, but should be less than 10. That is why it is a no. Next, it's a yes, because we have 2 which is greater than 1, but less than 10. So 2.09 or 19 times 10 to the 12th power. The next example is also a yes, because we've got 9.5 times 10 to the negative 7th power. And last example is a no, because the first digit should be equal to 1 or less than 10, and 0 is not included. It should be equal to 1 or less than 10. That is why it is a no. I hope you get that. Now let's move through the steps to write the number in scientific notation. Let's remember all these steps and apply this on a big number, which is 3,725,000. First, we have to move the decimal point to make the number greater than or equal to 1 and less than 10. And then, let's count how many places the decimal point moved. So, from that point, we could have the decimal point at the last digit, which is 0, and then we count that. We have 1, 2, 3, 4, 5, 6. Alright, so from the last 0, from the right to the left, we have 6 places until 3, which is greater than 1 but less than 10. We can now write the number without the zeros. So we have to drop all the zeros, so we only have 3, 7, 2, 5, the 9 zero digits, alright? So if we have 3, 7, 2, 5, next step is we have to write the number without the 0, then multiply it by a power of 10, and then the exponent will be the number of places the decimal point moves. So we have said a while ago that we have moved 1, 2, 3, 4, 5, 6. So 6 places. So that means it is 10 to the 6th power, right? So that is our correct answer. 3.725 times 10 to the 6th. Now I want you to try this. 14,140,000. Please do try to write it in scientific notation. Can you do that in 30 seconds? Alright, time starts now. Remember all the steps. You have to move the decimal point from the right to the left. And then count how many places the decimal point moved so that you would know what will be your exponent. After that, drop all the zeros and then multiply it by a power of 10, and then the exponent will be the number of places the decimal point moved. Are you ready? Let's check your work. So if we have 14,140,000, we have the decimal point at the end, which is after the last 0. So we have 1, 2, 3, 4, 5, 6, 7. Okay. So then we have 1.414 times 10 to the 7th. So remember, we drop all those zeros, we take away all of them, and then we just have to leave or retain all 9 zero digits, which are 1, 4, and 1, 4. And then multiply it with the power of 10. And then the exponent is 7 because we have moved the decimal point 7 places from right to left. That is why our final answer is 1.414 times 10 to the 7th. If you get that, you're correct. So how about this? Let's try to change or convert a small number to scientific notation. So remember, the steps are still the same. However, instead of moving from right to left, we are moving from left to right. And then let's count how many places the decimal point moved, and then we can write the number after that. So let's try to count it first. Okay, so we have from here the decimal point after the 0. So we'll have 1, 2, 3, 4. Okay, so we have moved from the 0 and to 3 because 3 is greater than 1 but less than 10. And then how many places? We have 4. That is why we could drop all the zeros and then we just retain those non-zero digits, which are 3, 1, and 6. So the final answer then would be 3.16 times 10 to the negative 4. So remember, we have moved from left to right, and that's why we have a negative exponent. Alright, so I'm giving you 30 seconds to try the following example that is at the bottom. Try writing 0.00876 in scientific notation. Okay, you can begin. Always remember that you have to move the decimal point to make the number greater than or equal to 1 and less than 10. And then, you have to count the number of places the decimal point moved. After that, you're ready to write the numbers or the number without the zeros, and then multiply it by a power of 10. Then the exponent will be the number of places the decimal point moved. I believe you are done. Let's check your work. So if you've got 8.76 times 10 to the negative 3, or 10 raised to negative 3, that means you are correct. Why? Because we have moved from 0, or the point here after the 0, and then 1, 1, 2, 3. That is why you've got 8.76 times 10 to the negative 3 exponent. Alright, so I hope that's clear now. To summarize what we have learned today, let's remember these things on converting a number, whether a big number or small number, to scientific notation. First, move the decimal point until there is one digit to the left of the decimal point. The exponent goes up when the decimal point moves from right to left. So that means it will give you a positive exponent. An example of that is 156,000. The final answer is 1.56 times 10 to the 5th. Why? Because we have moved the decimal point at the right to the left. And since from 0, 1, 2, 3, 4, 5, we have 5 places from the right to the left. So that is why we have 5 as exponent. And don't forget that we usually drop all the zeros. We only have to leave the non-zero digits. Except when the 0 is like between the non-zero digits, we still include that. But that would be like another lesson, okay? Now, the decimal point, when it moves from left to right, the exponent goes down. And that means it will give you a negative exponent. The example is this small number, which is 0.000053. And the answer would be 5.3 times 10 to the negative 6. Why? Because if we are moving the decimal point from after the 0, so we have 1, 2, 3, 4, 5, 6. So after 5, which is a non-zero digit, and that is like greater than 1, but it is less than 10. So that's why we have 5.3. We included 3 because that is the non-zero digit, but all the zeros are dropped or taken away. So we only have 5.3 times 10 raised to negative 6 because we moved from left to right. That is why the exponent is negative. I hope all these are clear with you. So this ends our discussion on converting a number to scientific notation. Maybe next time we can have scientific notation to standard form. So please don't forget to like, comment, share, and subscribe to Wing RB channel. Thank you for watching, and if you have any topic that you would like me to discuss, you could write it down in the comment after the video. And if you have questions as well, you could always write it. Thank you for watching. God bless you all. Bye.